Hey guys, welcome back. In this lecture, let's understand a fundamental concept to active asynchronous programming to make the system responsive. It's callbacks. Let's turn to Eclipse and create a program to understand callbacks. So here, I've created a class callback demo with main method and an interface callback. It's having single method call that we will use to signal the completion of any process running on a separate thread than this main thread. So as the main start, let's print something to show that the execution of main thread started. So let's print main thread is running. And let's create a separate thread that we will use to do some work concurrently or say asynchronously. And the task that we're going to execute, we will write that in a method. Let's say in a method public void running async. And here for now, let's print something like I am running on a separate thread. And let's say this task takes some time to execute and it takes 1 second. Let's create this method. And here we're gonna call thread.sleep on this thread with the duration that we are getting here. Let's call this duration. Let's enclose it within try catch. So now that we have written the implementation that we're going to execute on a separate thread, let's create a thread that will run this implementation. So here in this main thread will create another thread that will run this implementation, which is written inside running async. So let's create a runnable r equals to, here I'm going to use anonymous inner class, new runnable. Here comes the implementation. So let's add the run method here. And inside this run method, let's create the callback demo object. And then let's invoke this running async operation. So callback demo dot running async. So the thread using this runnable will certainly execute this running async method, but we are not getting any callback yet. To get the callback that signals the completion of asynchronously running tasks, we have to pass the implementation of callback interface here in this running async method. So let's pass callback. Now later, after the completion of this task, I can invoke the call method to signal the completion. So dot call. So here in this running async, we are going to pass the implementation to this callback that we are invoking here. So again, I'm going to create an anonymous inner class callback. I'm going with anonymous inner class to depict the callback clearly. You can go with lambdas as well, okay? So here, let's implement the call method. Yes, add unimplemented method. And here, let's print callback called. So we have created runnable. Now let's create the thread that will use this runnable. thread new thread, pass the runnable, and let's start this thread. Now we have to wait for this task to complete. So we have to put sleep, this main thread to sleep so that it doesn't terminate until the completion of the thread that is running parallelly. And finally print main thread completed. So let's execute this and let's see what we get. So main thread is running, then I'm running in separate thread, then callback call, and then main thread completed. So this is a simple example of callback, but when you are having multiple callbacks, it becomes very difficult to manage the callbacks as this is like a go-to statement and difficult to trace where the program pointer is during the execution. And this is called a callback hell. RxJava solves this problem by working on observer design pattern. And as we'll move further in this course, we'll see how observer pattern makes callback functions very easy. So this was all for this lecture. See you in the next one.